Hello everyone, this is Ashwini from Cheenta.com. Today I will be sharing with you how you can learn physics using both experimental tools and theoretical problems. You should ideally use both of these things together, and that's exactly what we do in the Cheenta Non-Routine Physics Olympiad program. You can check the link in the description. We want to develop a real intuitive understanding of the physical world, and we want to solve complicated problems. Both of those things, okay? So this particular software that I'm using now, it's called Algodo. I have shared the link of that in the description as well. It's a free software. You should definitely download it. It's a beautiful space to do physics experiments. So I'll show you an example that we can do. I'll use this box tool to create a little box up here. So this blue region is the sky and this green region is the land. So as you can imagine, if I click on this play button, of course this object that I just created will fall on the ground. Not only it will fall on the ground, it will bounce off a little bit. So if I speed up the simulation speed to 1, it will actually fall on the ground and bounce off a little bit. Let's put it on the top of the sky. So let's pause this and put it here. And now let's right click on this and click on the material button. So you will be able to see that there are several materials: glass, gold, helium, ice, stone, steel, and rubber, and stuff like that. So let's say if I click on rubber, it will change the density, the mass, the friction, the restitution, all of those things. The important part is this: when you are talking about physical properties of objects, this is a very beautiful way of changing the density, changing the coefficient of friction, changing the coefficient of restitution, and seeing what would happen in the real world. Even if you don't know what is restitution, let's say, if you just play with this, you can just change the restitution, the coefficient of restitution here. And even if you have no idea what is restitution, you will still see certain things happening. And you will probably be able to guess what is this particular coefficient measuring, okay? So this is what it is. Now let's talk about a little problem that we actually tried in the class, in the non-routine physics program at Cheenta. So it's a very simple problem. We were actually discussing this with like 6th graders. So they're just getting exposed to this idea of velocity, acceleration, and all of those things. So notice how we can talk about it. First of all, what I'll do is I will reduce the simulation speed as much as possible so that this actually falls very slowly. Now I will right click on this and I will click on show plot, this button. So of course you have to tell the kids a little bit about how a plot works, what is the x-axis, what is a y-axis, and so on. And you can change this to a time to y position. So I just change the y-axis to y position of what? Of this rubber object. So now what would happen is if I click on the play button, the rubber object will gradually fall, and here we will get the time versus the y coordinate of the rubber object. So the height of it above the ground, it will show that. And from that, we can actually understand what is acceleration. So let me click on the play button. So see, what's happening is the rubber object is falling. Of course, as expected, it's falling. Now let's click on the pause button. It's about to touch the ground. In fact, it has already touched the ground. it has traveled for 26.45 seconds where my cursor is. So when you are asking the kids to actually do this, they're learning to read data of a plot, which is a very important skill. Okay, so now what we can do is we can go to the top and we can see that the Y height is approximately 8.396. That's when the entire process starts. So I can actually click on here, and now as I go down, I can actually check every second how much the object has fallen. Now what kids realize is when they read this data and actually tabulate it, what they realize is the amount of fall in the first second is smaller than the amount of fall in the second second, and that's smaller than the amount of fall in the third second, and so on. So they, after they do the computation, after they do the table and they read the data of this particular picture or this plot, they actually realize that the velocity is increasing, the downward velocity, and not only that, they can actually calculate how fast it is increasing. And from there, we actually get the sense of acceleration due to gravity. So this is just for kids. Of course, we can do much more complicated stuff using this particular software, but I strongly urge you to actually test it out. I think it's a very good tool. And once you have this, you can actually talk about time versus speed graphs, time versus position graphs, and you can do some wonderful problems using that. In the last class, I think we worked on a problem from the All Russia Physics Olympiad for middle school students. We are translating this problem from Russian to English and putting them in the class. So one of them was actually on this particular graph. It's a very nice, simple problem, but you have to know how to think about these things. So to cap it off, make sure you are doing experimental physics and theoretical physics together. Make sure you are learning how to solve tricky problems on pen and paper, but also see those things in an laboratory setup. Of course, a physical lab is great, but also the simulated environments are also really nice. Okay? Alright, thank you for watching this video. I'll see you in the next one. Until then, keep on doing great physics and keep on doing great mathematics. Check the link in the description if you are interested in our outstanding physics and mathematics programs and computer science programs. I'm sure you'll like it. All right, take care. Bye.